Can taksi करना मैसेज करना
Okay, good evening to you all. Let's start today's lesson. It's 10 minutes past. Then, yes, first of all, I want to tell you that all of you did your presentations very well, and most of you presented some new concepts. That is very good, friend. Actually, in this type of distant learning methodologies, we expect that from you as adult learners. Um, So I'm very happy about you and all did well. So now we are at the middle of our course. Altogether, there are 13 units in this course. So now we are at the middle of this course. Therefore, I want to take your attention to our course outline, and then I will do a small summary on what did we do up to now, and then let's start today's lesson. Because from today we are going to discuss some kind of mathematical side in this because this is educational measurement and evaluation. No? Therefore, there are some statistical parts and also some mathematical parts, very simple. I think it's better to remind you all things. So, as I discussed with you in the first time, so this is our course outline. Altogether, there are 13 units. So, in our first session, we did educational measurement, assessment, and evaluation. So, we did some definitions on that, and then we compare what is measurement, what is assessment, what is evaluation. And there we discuss about several 4 types of measuring scales and all things we discuss on our first day. So then in our second session, we discuss about taxonomy of educational objectives. Under that, we discuss about, there are main 3 domains of education, cognitive, affective, and psychomotor. So then we discuss all 3 domains under B.S. Bloom's classification. So one by one we discuss there. Then we came our third session, that is on cognitive domain. In our third lesson, we discuss about measurements in cognitive domain and the development of test items in the cognitive domain. We covered in our third session both third and fourth topics. So there we discuss about Bloom's classification and also test items. In cognitive domain, we can you discuss about in your presentations also. So you have that idea. When we go to test items in cognitive domain, there are written test items and vocal or oral test items. You know about those things. So then we discuss about what are the advantages and disadvantages of these test items and those things. Then in our fourth session, we discuss about measurements in affective domain and measurements in psychomotor domain. They are in affective domain, we go to Simpson's classification, and in psychomotor domain, also we discuss that classification. There we Simpson's classification. There we mentioned that unlike psychomotor domain and cognitive domain, we can't take the assessment results at that point in affective domain. Therefore, there we discussed that we have to go several methods like observational methods, then attitude methods, personality tests. So we have to go to such type of tests in affective domains, especially unlike cognitive and psychomotor domains. So they are in some slides, I mentioned that they are in affective when we measure in affective domain skills, we have to use correlational coefficients. So I want to come to that point. Today, our session is, so up to session 4, we discuss about 6 units, measurements in psychomotor domain. So today we discuss about 8th unit. We are going to discuss about 8th unit, that is correlation and its uses. Thereafter, I will discuss 7 and 9 in next session. Because correlation and its uses are related to the measurements in all three, especially measurements in all three domains. And also we focus on affective domain measurements. So as a review, I would like to share you this. This is our last session, it means 4th session. So thereafter you did your presentations, and now we are on 5th session. So in our 4th session, we discuss about affective domain. There we discuss about steps of designing attitude tests. Under that steps, there we talk that define the component, and then we have to construct the statements with positive and negative. You can remember those things. Then there we have to construct a suitable ordinal scale, and we should build the statements, and we should distribute them among the random sample. And there, I told you that thereafter we have to calculate the correlation among those scores for individual statements and the total set of statements. Here, the first time we made the correlation, the word correlation here, that is related to affective domain regarding attitude tests. Thereafter, we discuss about personality tests, that is also on affective domain. Then as personality test, please mute your mics. In personality test, constructing personality test, there we discuss that we have to define the component and all the things, and then finally, based on the sample results, also we have to first check the results with the sample. Based on the sample results, we have to calculate the correlation among each item and the total test. There also we made correlation. So I want to remind you about those things. Today, we are going to talk about the correlation. This is our 5th session, that is educational measurement and evaluation. 5th session under education measurement and evaluation. So, wait. This is our today's topic, correlation and its uses. Under that, we are going to discuss about correlation, what is correlation and why we use them, and then what are the types of correlations, then what are the methods of studying the correlations. In detail, we will discuss about those methods, and then several exercises regarding calculating correlational coefficients. So actually, calculating correlational coefficient is very important. There we want to test your only test your whether we test that whether you can identify the correlational coefficient and all the things. We don't expect your mathematical skills here. Therefore, you can use your calculators and all things here. Actually, this is important as professionals. You all are professionals. Sometimes in near future, you may be SLES officers or SLTES officers. So at that point, this knowledge is very important because it reflects your professionality. Sometimes you have to take some decisions regarding some issues. Therefore, you can suggest, if we calculate correlation coefficient regarding this, we can get the solution like that. At that point, you can show your professionality. So that is, therefore, calculating correlation coefficients are very important. Not only for this exam or pass this course unit or anything, but that is very important for your future as education is. That is why I include in most of the universities and in this course, they omit this calculation part because it is sometimes it may hard for some students. Therefore, they omit. But this is not hard. In very simple way, let's discuss about those things. Then you can understand. Just take the idea only. Take the idea of those things. I invite you all, listen carefully and take that idea. So first, let's see what is correlation. So according to Ferguson, he said that correlation is concerned with describing the degree of relation between two variables. So correlation means relationship. Therefore, there should be two variables. He said that. So according to Guilford, a coefficient of correlation is a single number. That is a single number. That's correct. That tells us to what extent two things are related, to what extent variation in one go with variations in the other, how they relate with each other. That is that idea. He also talked about two variables and how they vary from each other. Therefore, correlation is a bivariate analysis. Bivariate means among two variables. Two variable analysis that measures the strength of occasion between two variables and the direction of the relationship between the measurements obtained. That is the whole idea. Then, to symbolize the correlation, we use R and rho. This is not P, this is rho, Greek letter. R and P. Here we use R for a small sample, means for sample. For a sample, correlation coefficient is called R. But for a population is the collection of a sample. They are collection of samples. Therefore, we use for a populational correlation coefficient, we use rho. So correlation coefficient differ from +1 to -1. It goes through 0, +1, 0, and -1. So always, if you calculate correlation coefficient, you have to obtain your answer within +1 and +1 and -1. Above, higher than +1, that is, if you obtain more than +1, greater than, your answer is greater than +1 or -1, that is wrong. Your answer is wrong. It means that. So correlation coefficient lies between +1 and -1. We'll discuss in detail. So then let's see what are the importance of correlation. It is very important, especially in psychology and education, as a measure of relationship between test scores and other measures of performance. As I told you, in all three domains, we use this correlation, especially in affective domain. With the help of correlation, it is possible to have a correct idea of the working capacity of a person by calculating the correlational coefficient or by using the graphical representation of the correlation. We can get the idea of the working capacity of a person if we measure the working capacity of that person. If our variable is on working capacity, we can get the idea on that. And also, we can assume all other variable qualities, various qualities of individuals. It means, as example, in some children take more marks for maths and they get low marks for Sinhala and other. And also some get more marks for Sinhala and other aesthetic subjects and they get low marks for mathematics, science and those logical subjects. So we can measure measure that they are possible. What is their level? What is their side? It means they may skillful in psychomotor domain, and we can get that idea using correlations. By taking that idea about by understanding the, by identifying the idea, by identifying the more skillful side of the students, we can help them to choose the correct side of A levels. After O levels, they can choose art subjects or science subjects or anything, and also we can give them vocational advisors, vocational guidance. Those are the importance. After finding the correlation between two qualities or different qualities of individuals, we can provide vocational guidance of them, as I told you. In order to provide educational guidance to a student in selection of his subject of study, sometimes in grade 9, they have to select their basket subject. So by understanding their suitable sides of the particular students, we can guide them to, you can select this type of subject from this basket, and like that we can guide the students. And also after O levels or after A levels, we can guide their parents also. We can give guidance for the parents. I can I can see that he is very skillful in this side, so it is better to go him in this side. Like that, we can give them guidance. So those are the importance of correlation and definitions. Then types of correlation. When we discuss about types of correlation, there are mainly 3 types of correlations. That is positive correlation, negative correlation, and zero correlation. Here I told you we use R or rho. So here I took R here. In positive correlation, the value of R is greater than 0. It means 0 to plus 1. It varies from 0 to plus 1. In positive correlation means if we take two variables as X and Y, X associated with Y in the same way. That is its idea. As example, if the weight of an individual increase in proportion to increase of his height, the relation between this height and weight is called positive correlation. In another word, we can say that it is proportional. It means if one variable is increasing, the other variable is also increasing. You may heard about the proportional. If one variable is decreasing, the other variable is also decreasing according to that. That is called proportionality. In positive correlation, always here we use only two variables. So there is a proportionality between those variables. That is called positive correlation. If it is zero, that is zero correlation. Then if the correlational coefficient is +1, that is called perfect positive correlation. Always that may not +1. That may 0.98, 0.8 like that. So it means that is near to +1. We called it higher positive correlation is high. If it is 0.2, 0.3, 0.4 like that, we call low positive correlation. There are those sides like that. We will discuss about it. Then the second one is negative correlation. That is totally opposite to positive correlation. It means if there are two variables, variable X is opposite to the behavior of variable Y. That is called inverse proportionality. Variable X is X shows inverse proportionality with variable Y. The example is given there. If the weight of an individual does not increase proportion to the height, like that. So that value, if that value is -1, that is called perfect negative correlation. It ranges from 0 to -1. This is just the introduction. Then we can calculate those things. So zero correlation means R equals 0. That is variable. There is no connection between two variables. There is no any proportionality inversely or proportional, no proportionality. So that is called zero correlation. That coefficient is 0. So as a summary of the types of correlation, this is, here I use the number line. If this, assume that this is the number line. So this is 0. 0. It means zero correlation. If the value is +1, that is called perfect positive correlation. If the value is -1, that is called perfect negative correlation. If we get the values between 0.5 to 1, it means 0.5, 0.6, 0.7, 8, 0.9, 0.75, 0.95, and in between 0.5 to +1, we called it positively high correlation, or another name, strong positive correlation. If our value is between 0 to 0.5, not 0, don't take 0.5 in this side, it goes to high side, 0.5 to 1. So 0 to 0.49, we called it positively low correlation or weak positive correlation. It means if the value is 0.1, 0.2, 0.25, 0.3, 0.4, 0.45 like that, we call positively low correlation or weak positive correlation. If the values are around 0, it means 0, 0.01, 0.02 like that. Yes, 0.01, 0.001, around 0, those are called zero correlation. If the values are between 0 to -0.5, that is called negatively low correlation or weak negative correlation. That is 0.1, minus 0.1, minus 0.2, like that. Then minus 0.5 to minus 1, we call negatively high correlation or strong negative correlation. In short form, we can represent it like this, the correlation like this. Then hereafter we are going to discuss about the methods of calculating or representing the correlation. Up to now, if you have any question, you can ask now. If you have any question, you can ask. Okay, then 8.3, the methods of studying the correlations. Mainly, there are two methods of studying the correlations. Those are using a scattered dot charts. It's like a graphical representation. Like we mark coefficients in the graph. That is like that. Then number 2, using the statistical methods and obtain a numerical relationship among variables. So, when using statistical methods, there are two types of correlational coefficients. Those are Spearman's rank correlation coefficient and Pearson's product moment correlation coefficient. Don't get excited about those things. These are only names. Both Spearman introduced a special formula to calculate it, and also Pearson introduced another formula. That's it. Using those formulas, we can calculate the correlational coefficient. So the thing is, you no need to memorize those formulas. But the thing is, if you see those formulas without those names, you have the idea. You have to have the idea to identify which type. What is this formula? Is it Spearman or Pearson's? Like that. I expect only that. No need to go in deep. So first we will discuss about how to represent correlations using scattered dot charts. Scatter graph or scatter plot graphs uses dots to represent values for two different numeric variables. We represent using numerical variables. So the position of each dot on horizontal and vertical axis indicates the values of individual data points. You know about that. Normally in the graph, we use horizontal axis is x-axis and the vertical axis is y-axis. So as you represent some data in the graph, it is same here. So scatter plots are used to observe relationships between variables. In scatter correlation diagrams, if all the points stretch in one line, all the dots are on one line, then that correlation is called perfect. And those data points have the unity. If not, if it is widely scattered, that is called, that correlation is very low. If the points are near to the line, then that is called, the data points are linear, not unity, but they are linear. We can obtain such type of data from scattered dot charts. This is indicating positive correlation using scattered dot charts. Here I gave you an example. The marks obtained by 10 students from mathematics and science are given below. Here, these are the marks obtained by 10 students for mathematics and science. It can be interpreted using scattered dot chart. Here, I took mathematics marks as x-axis or horizontal axis and science marks as vertical axis. So let's see. Student A took 70 marks for maths and 75 marks for science. That dot is 70 marks for maths, then 75 marks for science. That is here. So student A is here. Like that, using these data points, using these marks, we can mark the dots in this graph. You can see that these data points are scattered according to the particular direction. What is that direction? Using eight directions, what is this direction? Can anyone say? Because I want to check whether you are active here or not. What is this direction? Can anyone say? Miss Naduni, can you say? Miss Afra? Yes, miss, that is positive correlation. I ask you, what is this direction? This direction means when you divide this graph into 8 direction, that is these dots mainly lie on southwest to northeast direction, or in the normal in grade 6 to grade 11, you all use graphs in mathematics now. So in simple graphs, we can say if you draw a line, it is called the gradient. So this is called positive gradient. This is likely to have positive gradient. If we draw a line, if we draw a simple line, by connecting some of those data points, we can see that most of the data points are near to that line. That is called, therefore, and also this line has the positive gradient, or in other words, these data points are scattered from southwest to northeast direction. So this type of correlation is called positive correlation. And I told you there are perfect positive correlation, high positive correlation, like that. So these data points, if you draw a line, these data points are near to that line. Therefore, we can say that these data points have the linear connection, or these data points show the strong positive correlation, not perfect, but strong positive correlation. If I remind about that, it is like this. It lies in this area. Can you understand? It is positive. It means positive means 0 to 1. Therefore, from those positive, we have to identify in which part is it. Therefore, we can say that it shows positively high or strong positive correlation. Up to that, are you clear?
Yes, ma'am.
Okay. Then it is, which I told you, if all points stretch in one line, then it is perfect. But here, it is called positively high. As example, in industrial examples, the relationship between employment and inflation. We know if the employment, if we hire so many employers, therefore, the employee want to earn more to pay their wages. Therefore, the inflation of the product is increased. It is like positive correlation, the employment and inflation. High levels of employment require employers to offer higher salaries in order to attract new workers, and higher prices of their products in order to fund those higher salaries. That is a practical example. Conversely, periods of high unemployment experience fall in consumer demand. It means, therefore, we have to reduce the price of the product, resulting in downward pressure on prices and inflation. In education field, we can say that if we take mathematics and science, both are mostly both are in cognitive domain. Therefore, if one student shows, if one student gets more marks for maths, there is a trend to get more marks for science also. But that's not with Sinhala or other aesthetic subjects. So like that, there are so many examples in positive correlation. Then the second one is indicating negative correlation. Here the example is, we compare the monthly. Yes. Are there any questions? Here we compare the monthly test mathematics marks of 10 students and their number of absence days within that month. Here we want to find whether there is a relationship between mathematics marks within that month. That is monthly test, no? So within that month, monthly test, mathematics marks and the number of absent days of the particular students. Is there any correlation? If there is a correlation, which type of a correlation is that? There, from the register, we can take the number of absent days of those students. It is here. and then the monthly test marks. So student A got 30 marks and he absent 9 days during that month. Like that. Here, the monthly test marks are taken as horizontal axis or x-axis, and the number of absent days are taken as the y-axis or vertical axis. By indicating those points on this graph, you can see it like that. See, student A absent 9 days and got 30 marks. 30 marks and absent 9 days. A is here. If we take G, 70 marks and absent 2 days. Here, 70 marks and absent 2 days. Like that, we can represent the data points. Here, opposite to the positive correlation, we can see that the data points scatter along southeast to northwest direction. Southeast is this southeast to northwest direction. Or in graphical terms, we can say that there is the negative gradient. Negative gradient. If you take the graphs in mathematics in small classes, we can say that it has the negative gradient. So this type of correlation is called negative correlation. Here, if we draw the general line, you can see that some of the, not all, some of the data points are near with this line, near to this line. So this type of correlation is called negatively high correlation. It is this. Negative correlation means between 0 to -1. So in this representation, we can see that those data points lie between -1 to -0.5. So we can say that it has the negatively high correlation or strong negative correlation. Hope you can understand that. Actually, we can see that if the number of absent days are increased, usually the marks of mathematics may decrease. Unlike other subjects, especially mathematics, science, and also business, accounting. So the present percentage of the school is very important to gain marks of those subjects for students. This is regarding students. For adult learners, this may not valid because adult learners learn in several ways. Actually, most of you can understand that this distant learning method is very useful for adult learners. Otherwise, if it is face-to-face learning, it is very difficult to attend all lectures and all those things. So it depends on the nature of the learner. Here we discuss about the school students. For school students, they are not adults. Therefore, the present into the school is very important. So this is negative correlation. If variable x and y have correlation coefficient -1, that is which I explained you. For example, that is the relationship between household income and inferior products. Inferior products means a good whose demand drops when people's income rise. Demand drops when people's income rise. If the household income increase, what happened to the inferior products? As households make more money, they are more likely to consume less inferior more premium goods. If our income is high, we don't go for inferior products, we go for premium good products. That is it. Consider a human resources department noting that the less they spend on employee social events, the more likely to individuals are to leave the company. This is in business side. If the HR department give less attention to the workers, then they are tend to leave from the company. It means the less attendant, high tend to leave. Those are opposite to each other. Also consider a manufacturing plant that incurs less on the job injuries as more training is encouraged. If there is more injuries, therefore it means we have to give them training. Less training, more injuries. More injuries means less training. They are opposite. That is negative correlation. Then the third one is indicating zero correlation using scattered dot charts. It is the 10 students mathematics marks and Sinhala marks for a particular term test or anything. A student took 75 marks for mathematics and also 75 for Sinhala. If we go to F student took 86 marks for mathematics and 48 marks for Sinhala. If J took 23 for mathematics and 28 for Sinhala, we are going to see whether there is a correlation, which type of correlation among those marks. Therefore, in horizontal axis or x-axis, I consider mathematics marks, and in vertical axis or y-axis, I consider Sinhala marks. See, student A, 75, 75. So, he is here. Student A is this point, representing in this point. F, 86 to 48, 86. 86 and 48 for Sinhala. Yes, he is here. Then J, 23 to 28, 23 for maths. Yes, 28 for Sinhala. He is here. J is here. By looking at these dots, you can see that there is no any particular direction. We can't say that it lies along southwest to northeast or southeast to northwest. We can't say a particular direction. This type of correlation is called zero correlation. The dots scatter without any pattern. So here we can say that there is no any combination among mathematics marks and Sinhala marks obtained by those students. If it is, we have to find another reason for that. Then there may be another relationship between Sinhala marks and absent percentage or like that. We have to say. Or there may be Sinhala marks and the skill of the giving marks of the evaluator or teacher. There are some other correlations. If we take this type of correlation, it means there is no correlation between these variables there. If it is, we have to consider another variable. So as a summary for scattered dot charts, we can represent it like this. No correlation means if we draw any line in any direction, we can't say that they lies on particular direction. So this is called no correlation. This is positive. This has the positive gradient. So this is perfect positive correlation. This line is this. All points are lying on the line. So this is called perfect correlation. So it is like the correlation coefficient is +1. Here correlation coefficient is 0. Opposite to that, this is negative correlation, negative gradient. So this coefficient is -1. In between those, see, these lines have positive gradient, but they are not lie on the line, but they are near the line. This is called highly positive correlation. It means this, if we calculate the correlation coefficient, we can obtain +1 or +1 to -0.5 to +1 values. In this, these dots are scattered along southwest to northeast, but they are not near to the line. This is called low positive correlation. So if we calculate this value, it may be 0.5 to 0 values. Like that, you can see that these lines, these dots are also away from the line, or away from the negative line, but they are along this direction. They shows a particular direction, but they are not on that line. So this is called low negative correlation. If we go to the value, it may be 0 to -0.5. Here, the lines are near to the negative line. The dots are near to the negative line. So it is called highly negative correlation. If we calculate the value, we can obtain that -0.5 to -1 values. Actually, scattered dot charts are very good and very best way to represent the data and also represent the correlationship among variables. Because if we don't know, if someone assume that we can use this type of graphs to show the progress of the students to the parents using 2 subjects or other subjects. We can especially for A-level students, there is a high tend to absent to the school now. Therefore, we can use this type of scatter plot charts to show at the parents meetings what about their marks and their absent days. Like that, it is very best way to represent, because if the persons who don't know about any correlation, they can understand that trend. It is a symbolic way to express the correlation. It is very simple way, simple and normal and good way to represent data. But in practically, it means, as I told you, in a professional way, we have to calculate those things and verify. Yes, it is. If we can represent it using the scattered dot charts, but there are sometimes we have to calculate them and we have to prove that yes, it is like this type of correlation, like that. In your higher studies like masters, MPhil or PhDs, you may have to use this in your researchers, especially in researchers. You have to calculate those correlations. If you just represent those data in scattered dot charts, that's okay. But the validity is, in that point of view, the validity is low. To gain that validity, we have to calculate it. That's it. In normal ways, no need to calculate. That is the best way to represent and get the idea about variables. That is why the knowledge of calculating correlation is important for your future needs, not only for this course. So after the exam, you may forget about those things, but some in your future days, you have to use these things. At that point, you can take off those notes and refer those things. Then you can refresh your mind about these calculations. That is my aim. So then we are going to use the second part of studying the correlations, that is statistical methods to obtain a numerical relationship among variables. Before going to that, if you have any problems up to this point, you can ask now. Something is unclear for you or anything, you can ask. What can you say?
What kind of a question they would ask in the exam regarding this matter?
Yes, one way is we can ask MCQ questions. Using MCQ questions, we can just check your knowledge on these correlations. Or, wait, we can give you the data like this, and you can we can ask you to show which type of correlation among those variables x and y using scattered dot chart or calculating the correlational coefficient. Or not giving like that, I can ask like that. Using these given data, verify which type of correlation among those variables. There you can use scattered dot charts or calculate the correlational coefficient. So specifically, I can ask you have to, using those data, please calculate this type of correlational coefficient and interpret on that, like that. Understood, sir?
Okay, ma'am. Thank you.
Okay, to obtain numerical relationships, correlation coefficients are used. Correlation coefficient is also, as I told you earlier, -1 in between -1 and +1. In other words, it reflects how similar the measurements of two or more variables are across a data set. Mainly, there are two types of correlational coefficients. Those are Spearman's rank correlation coefficient. And the second one is Pearson's product moment correlation coefficient. So if you have a calculator or a phone better to keep a pen and a paper with you before going to the calculation of these correlational coefficients. It's easy for you to understand these calculations. Please get ready with those things. There are small calculations, so no need to do it manually, you can use calculator. In exam also, you can use calculator. So the first one is Spearman's rank correlation coefficient, rank. Here we have to give the ranks for data, that is called rank. The Spearman is the mathematician who found this formula, that is called Spearman's rank correlation coefficient. To use this formula, first you have to rank the data from each variable. You can get more understanding about this using from the next slide, that is on example. First, you have to rank the data from each variable separately from low to high. Every data point gets a rank from first, second, and third. It means here we give ranks for the variables from largest to smallest. It means the largest number gives number 1. So the second largest one give number 2, like that. It means descending order. We go to descending order here. Then you will find the differences between those ranks. That is the need. Between ranks of your variables for each data pair n, take that as the main input of the formula. So our formula is R equal 1 minus, within bracket, 6. What is this mark? Sigma. What is this indicate? In mathematics, this mark indicates what? Can anyone say?
Summation of.
Yes, very good. It is summation. Summation of differences of ranks, square of differences of ranks, d square. Divide by n into n squared minus 1. Here n is the sample size. It means number of students. So R is the rank correlation coefficient. D is the difference between ranks of two variables. D square is square of those differences and the summation of that. So no need to memorize this formula. In the exam, if you are asked the question regarding this calculation, we'll give you the formula. But we are not giving you the name like that. The Spearman's rank coefficient formula is this, like that. We don't give. We just, at the end of the paper, we will give you the all formulas. There are some other formulas, standard deviation formulas in future. Also, therefore, in the paper, at the end of the paper, you will get all the needy formulas without names, only the formulas. But among those formulas, you have to have the idea to find the related formula. That you have to have that understanding only. So this is the question. In the question, you will give you only these columns, only these 3 columns, first 3 columns. Student, marks from first examiner, and the marks from second examiner. You also discuss about these things in your presentations also, like reliability. Here, same question, same answer sheets, same 10 answer sheets of 10 students are given to the different examiners. And we are going to find whether there is a correlation among those examiners or not. This will give you the answer for that previous question from you. That is, if we can ask that, find whether there is a correlation or combination among the marks given by 2 examiners using the given data. Therefore, you can use scattered dot charts or Spearman's rank correlation coefficient to give the idea of that. We give only these 3 columns. So here, if you use Spearman's rank correlation coefficient, the equation is like that. R equal 1 minus 6 sigma d squared n divide by n into n squared minus 1. No question with n. No. N is number of students. We know that is 10 students are there. So 6 is a constant, 1 is also constant. So the question is with d squared. Here, as in the note said, first we have to rank the data. So this is the first examiner. So the rank of the first examiner's marks, rank Rx. So by examining this column, we have to find what is the largest number. You can see that the largest number is 82. So put number 1 here. So the second largest one is 80. That is, you have to put number 2 here. Like that. Third one is 74. For fourth one is 70. Fifth one is 65. Sixth one is 60. Seventh one is 55. Eighth one is 45. Ninth one is 30. And the last 10th one is 15. So here we give the ranks for the marks. Then also we have to give ranks for the second examiner, Y, RY. Here the largest number is 90, so we have to give number 1. So the second largest one is 83, here number 2. You can see that the third largest one is 75. There are two similar marks, 75, 75. It means third and fourth places are there. We can't give third or fourth places there. We have to get the median value of that. Between 3 and 4, in the middle of the 3 and 4, that is 3.5. Or you can calculate it. The third point, number 3, fourth point, number 4. So you can add 3 and 4. If you add 3 and 4, that is number 7. And divide them by 2. That is 3.5. So you can give 3.5 for both places. Not 3 and 4. Then fifth mark is 60. Fifth mark is 70. Sixth mark is 60. And the seventh mark is 58. Eighth mark is 50. Ninth one is 45 and 10th one is 27. Now here we rank the given marks. Still we are on the way of finding d squared. Now, using those rank values, we have to find difference of those ranks. To find the difference of those ranks, we have to use this modulus mark. Can anyone say what is the meaning of this modulus mark? Here I enlarge it. What is this? What is the meaning of this modulus mark? It is called modulus. Can anyone say? Do you have any idea? Modulus means whether the answer is minus or plus, we have to take positive answer. It means 4 minus, here we d equal rx minus ry. No. If you write ry minus rx, that is also okay. That is the meaning of that. It means 4 minus 3.5, that is 0.5. 2 minus 2, 0. 9 minus 9 is 0. 8 minus 8, 0. 10 minus 10, 0. Here, 5 minus 6, you can see 5 minus 6, the answer is minus 1. But here, in the difference, we consider modulus. Modulus means we don't put minus mark here. So we want only the difference. So the difference between 5 and 6 is 1. That is that idea. Understood? Then 6 minus 5 is also 1. 3 minus 5, 0.5, and these are 0. That is how to find D. D means difference of rank values. Then we have to square D square. 0.5 square means 0.25. Like that, we square those values. And then we have to take the sigma value. Sigma means addition, summation. So by adding 0.25, 1, 1 and 0.25, you can altogether, the summation is 2.5. So now we can all the data to calculate the Spearman's rank coefficient, rank correlational coefficient. So you have to substitute that to this equation. So R equal 1 minus 6 into sigma D squared. Sigma D squared means 2.5. Within 6 and sigma D squared, this is multiplication. And N you know 10. N squared 10 squared minus 1. You know 10 square, 6 into 2.5, 15. Divide by 10 into 10 squared means 100. 100 minus 1, 99. So now R equal 1 minus 15 divided by 990. So please, if you have the calculator or any facility, please tell me what is the value 15 divided by 990. What is that value? This value. 15 divided by 990. Please calculate and find.
0.0151515.
Yes, very good. Thank you, Miss. 0.01515 recurrent number here. Therefore, it is necessary. It is okay to have the answer with 2 decimal points. So don't go for 3, 4 decimal points. Therefore, our value is 0.015. 1515. So if you take near 3 decimal points, that is 0.015. Then you can round off 5 with 1. So that becomes 0.12. That is what I want to tell you. So therefore, the value of 15 divided by 990 can be taken as 0.02. So then R value becomes 1 minus 0.02. So there you can obtain the answer as 0.98. Understood? Do you have any questions regarding this calculation? Please go through these examples during this week. So it will be benefit for you. So our answer is 0.98, means plus, see, our answer is positive answer, no? So that is 0.98. So by looking at this value, correlational coefficient is 0.98. Which type of correlationship is this? Can anyone tell me? 0.98 means which type of correlation?
Highly positive correlation.
Yes, very good. Highly positive correlation because it is near to +1. So after calculating this R or correlation coefficient, as the final statement, you have to say that there is a highly positive correlationship among the marks from the first examiner and the marks from the second examiner. It means there is the reliability among those examiners. Like that, you have to interpret your answer. It's like this. R equals 0.98 means that there is a highly positive correlation between marks given by the first and second examiners. There is a consistency between the given marks. Hence, there is an agreement of marks when giving marks. There is a reliability and validity. Therefore, Spearman's rank, these are the explanation of our result. Then we can use Spearman's rank correlation coefficient to check whether there is a reliability of giving marks or not. Please remember about this example. We have to use the same example for next day's session. That is, in next session, we will discuss about reliability and validity. There we have to use this same example. In our sixth session. This is how we use Spearman's rank correlation coefficient. Are there any questions up to now? If you use the calculator, don't try to get the final answer at once. It will be giving several. It will be given you some incorrect answers. Therefore, when we type those numbers in the calculator, we have to be careful with the brackets. If we don't put correct brackets correctly, you will get another incorrect answer. Therefore, try to get the answer step by step. Even you use calculator, then you can get the reliable answer. If you type this type of big equation in your calculator, it will there is a possibility to give incorrect answer because of this type of brackets. So the best way is calculate it step by step like this. Are there any questions regarding this or up to this? Also, you can use in affective domain, we can use Likert scales. No, using Likert scales, we can obtain data from students or from the sample. So using, if our sample has 10 people or 10 students, and you can take two statements in your Likert scale as X and Y, and you take their responses. In the Likert scale, you can rank your answers from 1 to 5, no? So you can put those their answers here and here. Then you can calculate in the same way.
Mama, Mama,
Yes.
Ayama. Ano po? Yes, no?
Hello.
Ito lang ni Mione. Yeah. Ano? Hello?
Yes, miss.
The value of this D2 ma'am, we have to get
Wait.
the total.
Sulochana Rupasena, please mute your mic. Now you can say.
Ma'am, to get the value of D2, that is the 2.5, we have to get the total of that column, the whole column, is it?
Yes. Yes, means 0.25, 1, 1, and 0.25. So the addition is 2.5.
Okay.
Are you clear?
Yes.
0.25, 0.25 is 0.5. Then 1 plus 1, 2. So altogether 2.5. We have to take the addition of this column only. This one. Any other questions? Okay, then the second one is Pearson's product moment correlation coefficient. This product moment correlation coefficient was introduced by the mathematician Pearson. That is his name. The Pearson's product moment correlation coefficient is known as Pearson's R. Describes the linear relationship between two quantitative variables. Unlike Spearman's rank correlation coefficient, if you use Pearson's product moment correlation coefficient, there are several assumptions. So these assumptions are, so if you use Pearson's product moment correlation, your data should lie within those assumptions. So those are both variables are on interval or ratio level measurement. In the first, in the first session, we discussed about there are 4 scales: nominal, rank, interval, and ratio scale. There we talked that we studied that in nominal and rank data, we use qualitative. We use only for qualitative measurements, not quantitative. So nominal and rank are qualitative, but interval and ratio are quantitative. It means we can use them for mathematical calculations. We can't use nominal and rank data for mathematical calculations. So nominal means for males, we use capital M. For females, we use capital F, like that. So rank means we give the places of the in the class using the total marks obtained by the students in the class. We give, you are the first in the class, you are the second in the class, you are the 10th in the class, like that. So that is called rank data. So then interval means, in interval data, we talk about, we don't talk about zero level. That is Celsius, Fahrenheit data. Here we consider about range. Then in ratio level, there we consider about absolute zero level. Beyond zero level, we don't define any value beyond zero level. That is height, weight, price. Those are the ratio level measurements. So we can use Pearson's product moment correlation only for interval and ratio levels. But unlike that, if you use Spearman's rank coefficient, you can use, as I told you, for Likert, if you use Likert scale to find the attitude of the particular set of students, like saving the environment, so you can give two or four or more statements regarding to check the environmental, to check the attitude of their environment, saving of the environment. So there we define Likert scale. So that within that Likert scale, we take number 1 to 5 numbers. So that is in this type of data, we can use Spearman's rank correlation coefficient. So actually Likert scale is also in ratio scale, not ratio scale. Therefore, it is also, we can use here. In Pearson's product, surely our variable should be in interval or ratio level. Sorry, Likert scale is in interval level measurement. So in for Likert scales also, we can use Pearson product moment correlation. That's okay. So then the data should be from both. So the data from both variables follow normal distributions. There should be no any what do you call the skewness. Skewness means all data are in normal range. It means if you take numbers from, if our range is 0 to 100, so our data should be distributed within, in between 0 to 100. So if our data is, most of our data is distributed between 75 to 100, we can't use that type of data to calculate Pearson's product moment correlation. Therefore, both variables, so the data of both variables should be in normal distribution. And those data have no outliers. So they should be pure data. And your data is from a random or representative sample, random sample. And you expect a linear relationship between two variables, linear. It means proportional or inversely proportional relationship there should be. Proportional or inversely proportional relationship. If the relationship is not linear, like zero type, we can't use. That is it. Pearson's product moment correlation. If our data of both variables are in between, among those assumptions, we can use Pearson's product moment correlation. It is a parametric test. Actually, product moment. Pearson's product moment correlation is a parametric. That is why we call that we have to use ratio or interval level, and also we have to use normal distribution data. That is why we call it as a parametric test. And also it has the high power. Parametric means it has the high mathematical power than Spearman's rank coefficient. If you see that equation also, there is so many mathematical calculations there. It is much complex than Pearson's rank coefficient. Therefore, we have to use computers or calculators or some other Excel sheets also to calculate this product moment correlation. That is much complex. It is not a good measure of correlation if your variable have a non-linear relationship, as I told you. If any of these assumptions are violated, we don't use Pearson's product moment. There we have to use Spearman's rank correlation coefficient. As I told you, the formula for Pearson's R is complicated. But most computer programs can quickly churn out the correlation coefficient from those data. In a simpler form, the formula divides the covariance between the variables by the product of their standard deviations. So actually in the exam, we are not going to ask a calculation of any calculation regarding Pearson's product moment correlation. But you have to have the idea of identifying the equation only. Don't get excited. Don't need to calculate this formula. This is a Pearson's product moment correlation. This is R equal N sigma xy. Xy are two variables. Then sigma x, sigma y, and see the square root of this part and square root of this part. N sigma x squared minus sigma x total squared. Like n sigma y squared and sigma y total sigma y squared. N is the sample. N is the sample or number of the students, number 8, 10 or like that. So sigma is, as you told you, sigma is the addition. So x is the addition of all x variables. Sigma y is the addition of all y variables. Then we have to separately multiply x values and y values. So that is the addition of xy. Then also we have to square all those values. That is, then take the addition of those values, x and y. If you calculate, if you go to the calculation, you can get the idea of that. This is the mathematics marks obtained by 10 students from first and second term tests are given here. Mathematics marks for first term test as X, mathematics marks for second term test as Y. So these are 10 students are there. Here, if the formula is complex, we have to find only these things, x squared, y squared, and xy, and get the summation of that. See, these are x values, 75, 34, 45, like that. Then we have to square this value. 75 square means 75 into 75, that is 5625. Then 34 square is 1156. So these are the y values now. So then separately we have to square these values. 75 square 5625, then 83 square 6889, like that. 20 square 400. These are those values. Then we have to multiply x and y values. 75 into 75 again 5625. Then 34 into 83 2822. 45 into 20 900, like that. we take x, y values. And then finally, we have to take the summation of all these columns. Summation of x column, summation of y column, summation of x squared, summation of y squared, and the summation of xy. So for our calculation, we need only these summation values. You can see it in the calculation. If you use Excel sheet using formulas, you can take these values automatically in the Excel sheet. So in sigma xy here, sigma xy you can say 28,538 is the value of sigma xy. Then you have to multiply it by n. N is number 10 because there are 10 students. So we multiply it by 10. That value is here. Then sigma x into sigma y value. See, sigma x, sigma y. Sigma x is 31,889. Sorry. Sigma x value is this, 517. And we have to multiply it by 532 like this. So separately take those values. Then take n into sigma x squared. N is 10 and sigma squared value is 31,889. So we multiply it by 10. So that is this term. Then put minus mark and take total sigma x squared. Sigma x means 517. 517. We have to take the square of 517. And then we have to take the difference of these values and take the square root. That value is 227.158535. As I told you, we round off it to the 2 decimal points. So answer is 227.16. Like that, we can calculate this part, n sigma y squared. See, sigma y squared is this column. That is 32,928. We have to multiply it by n. That is this. And minus sigma y squared. Sigma y is this 532 and squared. And take the difference and take the square root. So then you can obtain 215.07. By obtaining these values separately, and finally you can calculate R here. R equal n sigma xy means this value, no, minus this part, and divide by these two values, 227.16 and 215.07. So you will get the answer of 0.21. So our answer is positive. It means positive correlation. So 0.21 means 21. That is positive correlation, but that is not strong, no? Weak positive correlation. R equals 0.21. So the explanation is the correlation among first and second term test marks for mathematics is very weak. So according to those marks, there is no correlation among first and second term marks. No correlation means zero, not no correlation, but the correlationship is very weak. Then, as I told you earlier, we have to find another correlation which varies with mathematics marks. So are there any unclear things about this calculation up to now? If you have any questions, please ask. Surely we are not giving the calculation like this from this Pearson's product moment correlation. Surely we are not giving you any questions to calculate, but you have to understand the formula. Are there any questions? So as the summary with the scatter plot charts and correlation, in the previous slide, I explained you about the scattered plot charts, and here the correlation values are given here. R equal 0, R equal -1, R equal +1. So low positive correlation means R equal 0.3. This is only for example. It means this is between 0.0 to 0.49. This is between 0.5 to 1. Highly positive correlation. In low negative row correlation, the value is like negative, -0.3 example. So then highly negative -0.8 or 0.98 also we obtain, 0.21 also we obtain, no? Then perfect negative correlation. So this is the last part, exercise. So explain these are the questions like that. You will obtain. Explain the correlation between the mathematics marks obtained by 8 students and the number of days they absent during the term by calculating the Spearman's rank correlation coefficient. We use this type of example to find the correlation using scattered dot charts. But here you have to find Spearman's rank correlation coefficient. And from the second question also, you have to obtain Pearson's product moment correlation coefficient for these data also. And if you calculate this Pearson's product moment and Spearman's rank correlation, you will obtain not same answer, but similar answers. So actually, please do these examples, then you can get the idea. And also calculate Pearson's product moment, so then you can get familiar with these equations. It may not take more time because you can take computers or calculators anything, and just try to do these values. Try to get these values as activity. So then if you want to find Spearman's rank correlation, then you have to remember what is that equation. That is R equal 1 minus 6 sigma d squared, like that. There we have to find only d values. No, to find d values, we have to first we have to give ranks. Like that, you have step by step you have to remember those things. So then this is x, then you have to give rx here, ry here, then take difference of these. There you have to remember that we used no mark there. Rx, ry, if you get the minus value, Rx minus Ry, we obtain only positive values. Modulus mark there. Then obtain d squared, and you have to take only the summation of d squared. Not like Pearson's product moment, we have to take summation of all these columns. But in Spearman's rank correlation, we have to take the summation of only t square values and then substitute it. If you want to find Pearson's product moment, you have to take the summation of x and summation of y. Then you have to take square of x values and summation, square of y values and summation. Then xy product values and get the summation. So then no need of this last column. So the necessity is we have to calculate all the summation of these columns and get the values and substitute those values in the equation. So this is the last question. The marks given by 2 examiners for a particular test is given below. We did the example like this also. This is for 80 students. Then you are asked to calculate Spearman's R and explain the correlation. If you are given the chart like this, chart like this, you have to redraw this chart in vertical way. This is the horizontal way. No? So in the first column, that is answer script or student A, B, C, D, E, F, G, H like this. In the second column, that is X values. Then the third column, Y values. Then you are asked to Spearman's R. So you have to find Rx, Ry, D value and D square value and take the summation of that. Most probably you will get the questions like this. If you are given the questions like this, you have to redraw this chart in vertical manner and then calculate the relevant formula using the relevant formula. So these are the things I want to discuss with you today. So as a summary, we discuss about correlation. There are 3 types of correlation: positive, negative, and zero correlation. Then there are 2 methods of calculating correlation. That is using scattered dot charts and also calculating correlation coefficient. Then using scattered dot charts also we can obtain positive, negative, and zero correlationships. And also that is the best way to represent data. And also by looking at the scattered dot charts, we can take the whole idea, unlike calculating. But there are some incidents we have to calculate and prove it. Therefore, in such circumstances, we have to use rank coefficients. In our syllabus, we discuss about 2 rank coefficients, that is Spearman's rank coefficient and Pearson's product moment correlation. For the given data, if you are given the data set, assume if you are given the data set like this, you can do any calculation which we discussed today from this data set. It means you can represent this data set in scattered plot chart, and also you can calculate Spearman's R, and also you can calculate Pearson's product moment correlation coefficient. So all those things, you can use all those things for the given data set. Do you have any questions? You can ask now. That is the end of today's session. If you have any questions, you can ask. Remember that you have to upload your second assignment to the LMS at the particular date. If you have any questions, you can ask now. So please try to do these exercises. That will give you a good practice how to use these things, and also don't wait until the final moment of the exam. So please keep in touch, because you are working with several subjects, and also you are working people. So try to keep in touch. Don't excited about these mathematics. It's simple. So just try to get the idea only. No need to go through, go in deep. Okay, if you don't have any questions, we can wind up today's session. Okay, then thank you very much and good night to you all.
Good night. Good night, ma'am.
Thank you, ma'am.